This video is on integration using residues. In today's video, we are going to solve the problem using residue theorem. So in this video, we have to evaluate integral 2 into e power z by z into z minus 3 into dz, where c is mod z is equal to 2 by residue theorem. See here, this is integral f of z into dz. See here, clearly f of z is nothing but f of z is nothing but 2 into e power z by z into this is z minus 3. So first of all, we have to find the poles for this function. So for this function, in order to find the poles, as usual, we have to equate the denominator to 0. So if I equate the denominator to 0, then this will be z into z minus 3 is equal to 0. If I equate z is equal to 0, so clearly z is equal to 0 is one pole, and next one z minus 3 to 0, so z value is equal to 3. So here I got two poles as z is equal to 0 and z is equal to 3. See here, the circle here given is mod z is equal to 2. Clearly from the question, what is given? Mod z is equal to 2. Mod z is equal to 2, and let us see how we can write this. So we can write this as z minus 0 is equal to 2. So it is a circle with center 0 and radius 2. So let me show you this one. So this is 0, this is 1, and this is 2. This is minus 1 and this is minus 2. This is plus I and this is 2I. Here this is minus I and this is minus 2I. See here, we have to take 0 as one center, center 0, and we have to take 2 radius, and we have to draw a circle like this. So this is the circle. So in this circle, within the circle, so here 3 will be there, outside 3 is there, and therefore 0 is inside the circle and 3 is outside the circle. So for outside the circle, we no need to find the residues, and we have to find the residues for the points which are inside the circle. So now we have to find the residue at the point z is equal to 0. So of these, among the poles z is equal to 0 and z is equal to 3, only z is equal to 0 is inside the given circle, that is mod z is equal to 2, and therefore there 3 is outside the circle. Now the residue for f of z at point z is equal to 0 is, so at the point z is equal to z naught is, this is limit z tends to z naught, z minus z naught into f of z. Clear? And therefore this is limit z tends to 0, this is z minus 0 into f of z. So what is f of z here? F of z is nothing but 2 into e power z by z into this is z minus 3, and therefore I can cancel the z. And see, in the rest of the function, if I substitute 0, this is 2 into e power 0 by 0 minus 3, and therefore anything to the power of 0 is 1. So this will be minus 2 by 3. So here the residue value of f of z at point z is equal to 0 is minus 2 by 3. So now we have to apply residue theorem. So according to our residue theorem, according to our residue theorem, so what is the statement? So this is nothing but integral, this is integral f of z dz is nothing but 2 pi I into the sum of the residues of the interior poles, sum of the residues of interior poles. So here interior poles is z is equal to 0. So this will be, so the answer will be, so this is integral f of z. So integral f of z dz is equal to, that is 2 pi I into here minus 2 by 3. So the answer here is minus 4 pi I by 3. Minus 4 pi I by 3 and integral. So what is f of z? That is 2 into e power z dz by this is z into z minus 3. So for z into z minus 3 are value is minus 4 pi I by 3. So let me explain once again. See here, clearly it is given integral f of z into dz. So I have taken f of z from this function. So in order to find the poles, we have to equate the denominator to 0. After equating denominator to 0, I got two poles, z is equal to 0 and z is equal to 3. Of these poles, see, let us check which pole is inside and which pole is outside. Here, the given contour z is equal to mod z is equal to 2, and this can be written as a z minus 0 is equal to 2. So this is a circle with center 0 and radius 2. So this is a circle with center 0 and radius 2, and therefore 0 is within the circle and 3 is outside the circle. So we have to leave the outside pole values, and the residue value at z is equal to z naught formula is limit z tends to z naught, z minus z naught into f of z, that is z minus 0 into f of z. So after cancelling z, and we have to substitute z is equal to 0 in the rest of the function, and this is minus 2 by 3. And according to the residue theorem, we have integral f of z dz is nothing but 2 pi I into sum of the residues of the interior poles, that is 2 pi I into minus 2 by 3. This is nothing but minus 4 pi I by 3. Thank you so much for watching. If you really understand, please look at my next videos also, which are uploading very soon, and those are also very, very important. Please, if you really like, pass it on to your friends.